Hello guys, my name is Lucas, and in this video you'll learn how to install and use the LLVM test suite. So let's understand what is the LLVM test suite first. The test suite is a set of programs written in C or C++ or a combination of C and Fortran. And with these programs, we can test the LLVM compiler. So we can test the correctness or the performance of the compiler. Also, we can test LLVM-based tools. So we can use the test suite as assistant of LLVM developing process. You can use the test suite to test your tool or your optimization during this process. So, okay, let's learn how to install the test suite. I separate this process in three steps. The first one is the requirement. The second, the download process. And finally, the compilation process of the two. So let's see the requirements. You need the CMake to configure the compilation files. Also, you need the LLVM lead tool. So the lead tool is the test runner we will use to run the test. There are two ways to obtain this tool. You can install it using the PIP, or if you already have a LLVM build, you can find it inside the binaries of your build. And about the downloading process, there's two ways to download the test suite. The first one is cloning the repository on GitHub, and the second one is using the wget and extracting the tar gz. So in this process, make sure to download a compatible version of the test suite according to your compiler. So if you're using the LLVM compiler version 17 clone, or check out the version 17 of the suite, or download the targz of the version 17. Okay, now we have the source files. Let's learn how to compile the source files. The first thing we need to do is to create a folder to build our build. So here we create the test suite build, and inside this folder, we will configure the compilation files by using the CMake, passing the path to my compiler. So in this case, you can use your LLVM build and passing this flag O3. It is inside the test suite folder. And finally, you pass the test suite directory. This test suite directory is the source file of test suite you have downloaded before. And one thing you need to remember, if you're using your own build of LLVM, you need to enable this flag. So you need to rebuild the LLVM with this flag. With this flag, you will be able to compile all the benchmarks inside the test suite. Without it, we will compile just half of them because the micro benchmarks need to this flag to compilation process. So okay, after that, just use make and wait to the compilation process ends. Now you have a build of the LLVM. Let's understand what do we have in your hands. So the structure of the test suite build is the following. We have a single source folder. Inside this folder, we have programs that are our only single source file, so are simpler programs. And we have the multi-source folder. In this directory, we will find programs written in multiple source files. So we can find large benchmarks and whole applications here. And we have the micro benchmarks. This is the benchmark we need to enable the flag I mentioned it before. And in this directory, we have programs that use the Google Benchmark library. So these programs need to be run several times to get a statistically significant result. And finally, we have the external directory. So if you want to add new benchmarks or suites, we can add them in this folder. So, okay, now let's understand the LLVM integrated tester or the lead tool. as I mentioned before, the lit is a requirement to run the test. Lit works like a test runner for the LLVM test suite. And with this tool, we can run individual tests or entire directories. So we can pass a single program or we can pass an entire directory and the lead will search in this directory all the test files and run each of them. And the common options we can pass to Little are the output file. So the output file will be a JSON file, the number of workers, so the number of CPU cores you want to allocate to run the tests, and this minus v is a verbose output. So when a test fails, the output will be more detailed. And now let's see how to use the LVM test suite. I choose some examples to exemplify how it works. So here the first one. Here I'm calling the LLVM lead, I'm calling the test runner, I'm passing the minus v flag to a verbose output. I'm allocating just one core to run the test, setting result.json as the output file, and passing dot as the directory. So here I'm running for the entire test suite. So just remember, I'm running this command inside the test suite build. So in this case, delete will search all the tree of test suite build for test files and run the test for each of them. Other option is running for a specific benchmark set. So here it's the same command, but I choose for workers, and I'm passing the single source folder. The delete will search for the tests of the programs inside the single source and run the test for each of them. Or even more, I can specify a single benchmark or a single program if you want. So in this case, I'm calling the delete, passing for workers, and I choose the single source benchmarks polybench as directory. So this command will run the test only for the polybench benchmark. And the results of this case will be something like this. So the first line indicates the number of test files lit found in the directory, the number of works allocated to run the test, and for each of these tests, they will indicate if the test pass or not, and we can find some metrics of the execution of the test, so like the compile time, the execution time, etc. And finally, let's learn how to add external suites. The first thing you need to know, these tests or the suites and benchmarks you need to add must be compatible to the test suite of LLVM. What it means? They must follow the same structure used in the benchmarks from test suite. Delete must be capable to run them. And we can add the suite in the external folder. It's like you need to take the source files of the suite you want to run and put them in the external folder. Just that. And other option is link the suite. This option we can use for suites that LLVM supports more, like SpecCPU, because we have a flag during the CMake process, the compilation process, to specify the path to the spec CPU, for example. So we can use this flag and pass the path to a build of spec CPU, and the LLVM suite and the spec CPU will be integrated without any work. And here we reach the end of our tutorial, of our presentation. You can learn more about LLVM suite in this reference. They will be in the description of this video. If you have any questions about this video, you can let the question in the comment section or contact me in this email address. Feel free to watch our other videos in your channel and visit our lab website. Thank you for watching and bye.